Hello, everybody. This is for my Wednesday class, February 3rd, and Thursday class, February 4th. Now, compared to Monday and Tuesday, I think this is kind of a much easier lesson. So hopefully this video won't be a full hour. I'll see what I can do. All right, so tonight we're going to talk about relations and functions. So a relation is pretty much any set of ordered pairs. There's not really any rules that they could, break. If you have a set of ordered pairs, you have a relation. But a function means that for every x value, there's exactly one y value. Or another way to say that is there is one unique output for every input. Also, if you look at the screen, a function can pass the vertical line test, which I'll show you what that means, and does not have repeated x coordinates. The other two words we'll look at are the words domain and range. So domain are all the x values, and the range are all the y values. One way to keep them straight is that x comes before y in the alphabet, as does D comes before R. So both of them are, in order alphabetically. Domain goes with X and range goes with Y. So a relation is any set of ordered pairs. The domain is all of the all the first coordinates, which are the X, and the range is all of the Y or the second coordinates in a relation. So for example, all we have to do on this problem, first of all, R equals, so that squiggly marks means this is a set of ordered pairs, so this represents a relation, and they want us to find the domain and range for the relation. All you have to do is list the x values, and for the range you're going to list the y values. So the domain include 5, 6, and -2, and I don't have to repeat the 6. I don't think Hawks will count it wrong if you do repeat it. I'm not sure, but anyway, you don't have to repeat. If you have the same number, you don't have to write it twice. And then the domain are the y values, 7, 2, 3, and -1. That's it. Domain and range, the x values and the y values. So what about this one? What are the values for the domain? So the domain include -1, 1, 3, and 4, and the range are the y values. So we have 1, 5, and 0. Easy peasy. So a function is a special type of relation in which every domain element, or for every x value, there's exactly one range value or exactly one y value. A function is a relation in which every domain element occurs only once. So for example, when you're trying to figure out if a relation is a function, you're really only concerned about the x values. So do you see here that we have two x values of the number 2, and those are paired with a different y value. So since it's telling us that the x value 2 has two different outputs, this is not a function. Now, it doesn't really matter, if your y values repeat, it doesn't matter. All it matters is if the x values repeat. If they do, then it is not a function. All right, let's look at this one. We have unique x values. All of the x values are unique, and so it is a function. Yes, function. So for every x value, there's one unique y value. All right, look at this one. So we have the x value 1, 3, -2, -1, and -4. Now, like I said earlier, even though all the y values are the same, it doesn't even matter. As long as every x value is unique, It is a function. Yes, this is a function. So that's what you're looking for, the x values. All right, so now we're going to look at this situation. It says, consider the following relation. Why is it a relation? Because it's a set of ordered pairs. First of all, we're going to determine the domain and range for the whole relation. And then we're going to see if the relation is a function. So basically, if we take each ordered pair and we write it down, so this ordered pair is -1, 4. This ordered pair is -4, 1, 2, 3, -4, 3. This ordered pair is -3, -1. And this ordered pair is -4, -5, -4, -5. And now it wants us to identify the domain and the range. Well, all you have to do is, for the domain, list all the x values. So we have -1, -4, -3, and the last one is -4, which we already have, so we don't have to list it again. And the range values are the y values. So we have +4, +3, -1, and -5. And you don't even have to put them in numerical order. Just list them as you see them. So we listed the domain and we listed the range. And then it says, is this a function? Well, if you look back at the ordered pair, you see that the x value of -4 goes with +3 and it goes with -5. So is it a function? No, it is not a function. And then it says, if it's not, identify two ordered pairs as proof. So to prove it's not a function, we're going to list -4 and 3. And the other one that makes it not a function is -4 and -5. So this is our proof of why this is not a function. And you're going to have to do all of that in HAWX. You have to list the domain, the range, and then you have to determine whether it's a function. And if it isn't, you have to list the reason why. So then one way we can prove that something isn't a function is by doing what we call the vertical line test. So if you have a picture, so ignore all of those dots, just look at the blue dots, just the blue dots. If that was our picture, or that was our set of ordered pair, then we would conduct what we call the vertical line test, which is demonstrated by that dotted line. So basically they took a vertical line and they said, okay, we're going to go through those ordered pair, and if I go through two ordered pair, I know it's not a function. So because this vertical line, the graphed points failed the vertical line test because we went through 2 points with the same vertical line. If that happens anywhere on your ordered pair, it's not a function. So we could have done our vertical line here as well, and we would have gone through 1, 2 points on the same vertical line. So it would have failed on this vertical line, and it would have failed on this vertical line as well. So when you draw a vertical line, if you go through any of the ordered pair more than once, or through 2 of them, it's not a function. So this is not a function. All right, let's look at this half circle. So they drew 3 vertical lines, and in all 3 situations, they only went through the picture 1 time on the same vertical line. So is this a function? Yes, it is. It passed the vertical line test. What about this? So they drew this vertical line and they said, uh-oh, I went through the picture here and here. If it happens anywhere on the picture that's graphed, it's not a function. Not a function. It failed the vertical line test. All right, what about this thing? This crazy thing looks like an S. Does it pass the vertical line test? It goes through once, twice, and it actually goes 3 times on the same vertical line. So this is not a function. Not a function. It failed the vertical line test. Now, one we get a lot is a picture that looks kind of like, this is your graph. If we have this thing right here, this is not, yeah. Is this a function? This is a function, yes. Because I could draw vertical lines and it would only go through my picture once. But if you noticed, when that U is sideways, like this one, it's not a function. But the one I drew right here, it is a function. All right, what about a vertical line and a horizontal line? So let's say this is my graph, and I have a horizontal line. Let me do a blue line. Let's say this is my picture. Is this a function? Would it pass the vertical line test? Yes, this is definitely a function. It would only go through, my vertical line would only touch that picture one time in each vertical line. However, if I had a vertical line, so here's my graph, and if I had a vertical line drawn, let's say this is my picture, and that's my picture that's graphed. And then if I did a vertical line test, every single point, it would go through every single point on this vertical line. So vertical lines are not functions. That is not a function. That definitely fails the vertical line test. That is a vertical line. So horizontal lines are functions, but vertical lines are not functions. All right, so let's look at this one. It says, consider the following relation, determine the domain and the range for the interval, for the relation and interval notation. All right, so the domain, remember that's your X values, and the range are your Y values. So if I wrote out all these coordinates, so let's start with this one. If I wrote out this coordinate, I would write -3, 3, -3, 3. If I wrote out this coordinate, it would be -1, 3, -1, 3. What is this coordinate? It's -1, 1. And this coordinate is -3, 1. So I want to know what the domain is. What is the domain? What are the domain values? It's the X values, right? So the X values are those first numbers. So what do you notice? Now, this isn't just dots, these have lines. So this basically says if we're starting at -1, and then there's a line that means it could be 1.1, 1.2, 1.3, 1.4, all the way up to 2. It could be 2 and all the way up to 3. So we have a range of numbers for our domain from, I started with a parentheses, but look, this is a solid dot, which means it includes the range from -3 to -1. It includes, remember we have to write these in numerical order. -3 is the smallest, -1 is the largest, and it's a range of numbers from -3 through -1, and it includes everything in between. Isn't that all of our X values, -3, -1? And there's a line that goes, and it includes everything in between there. So that's the domain. So now the range are the Y values. So look at all the Y values. The Y values, and once again, we have filled in dots. The range includes all numbers from +1, look at all the Y values, through +3, and it includes both of those numbers. So this is the domain and this is the range. Okay, now if those circles were open, we would use the parentheses. That's from our very first lesson. Now let's look at this one. It says, consider the following relation, determine the domain and range for the interval for the relation and interval notation, determine if the relation is a function. If it's not, identify two ordered pairs as proofs. All right, so that's a vertical line. So first of all, before I determine that it's not a function, which we already know because we've already talked about that, right? Let me change colors. That green might be hard for you guys to see. All right, we'll do purple. All right, so first of all, what's the domain? The domain are all of the X values. So if we wrote out all of these ordered pairs, every one of them would start with -5, -5, 4, -5, -5, 3, -5, 2, so on and so forth, right? -5, 0. This will be -5, -3, so on and so forth. So what is the only domain value? The only domain value is -5. That's it. So that goes in a bracket because that's the only one. Now for the range, since you notice it's an arrow, it goes down forever and it would go up forever. So how do we show on a number line? How do we show both ways forever? So the range would be from -infinity through +infinity. Since the Y values would go down forever and up forever, it would be from -infinity to +infinity. And remember, infinity always gets a parenthesis. Oh, I'm sorry. And then, is this a function? This definitely fails the vertical line test, right? Is it a function? It is not a function. No function. And then the next statement is, give me 2 ordered pairs that prove it's not a function. Well, you could take any of those. You could take -5, 0, the y-intercept, and any other pair, excuse me, any other ordered pair where that x value is -5. Any 2 pairs would make that we would prove that it's not a function. All right, what about this one? Now this one, you notice we have open circles, correct? We don't have the filled in circles. If we have filled in circles, we use brackets. If we have open circles, we use parentheses, right? So one way that it's easy to figure out the domain and range is if you take your picture and you draw a rectangle around it. So I want to show how wide and how tall my rectangle would be. Okay, so the domain are the X values. So basically, I want to know how far to the left and how far to the right does my rectangle go. So my rectangle comes all the way out here to -1, 2, 3, 4, 5, right? You see that? On the X axis, it comes out to -5, and I'm using a parenthesis because that's an open circle. And it comes up through what? What is my X value? Right here. This is +1, right? So domain is from left to right. Now range is from bottom to top. How tall is my rectangle? Well, you got to put them in numerical order. First of all, we're using parentheses because of those open dots. Now what's my lowest Y value down here? My lowest Y value is -1, 2, 3, 4, 5. Up through, what's the highest point? So here's the highest point. I want to see it on my Y axis. My Y axis is +1. So these happen to be the same, but that's unusual. They're not usually the same. But what you'll do is you'll take your picture, you draw a rectangle around it, and then for the domain, you want to know how far from left to right. And for the range, you want to know how tall from bottom to top. And you have to put those in numerical order. All right, what about this picture? So we're going to draw a rectangle around the whole picture. I'm going to draw a rectangle. Y'all see what I'm talking about? Draw a rectangle. Oh my goodness, my throat is so dry, you guys. Hold on one second. Sorry. All right, so domain is from left to right. You see that? From left to right. So we're interested in our x-axis, how far from left to right. Once again, these are open circles. We're using parentheses. So we are going from -2 to +2. That's our domain. And then our range is from bottom to top. So bottom to top. How low does our picture go? Our picture comes way down here at -1, 2, 3. Oh, actually, since even though these are open circles, since this touches -3, do you see what I'm talking about? This touches -3, we're actually using a bracket down here. And then it goes up to, and then there's our open circle. Do you see that? At +2, and so we have to use a parenthesis on the top, because this is our top line is an open circle. But down here, it actually touches -3. So, excuse me. I'm having a hard time tonight. So you guys got to be careful on those signs, okay? So hopefully everybody sees why it's a bracket on -3, because it's touching that line. All right. Now let's look at these. So we're determining, first of all, the domain and range of each. And then we're determining whether or not each of these is a function. Okay, so for the first one, where you're thinking of these dots with their coordinates. So this coordinate is -2, 4. I'm going to write it out, -2, 4. This coordinate is -1, -2, -1, -2. This coordinate is 3, 3. And this coordinate up here is 3, 4. All right, so for the domain, all we want are the x values. So what are the x values? They're -2, -1, and 3. What are the range values? The range values are 4, -2, 3, and we've already listed 4, didn't we? So we don't have to repeat that. So those are our domain and range. Now, is this a function? Well, look at your ordered pair. Do you have any x values that repeat? You sure do, right? So this is not a function. No, it's not a function. And if you had to list 2 coordinates to prove that it's not a function, these are the 2 you would list. All right, let's go to this one right here. First of all, it wants to know the domain. So we're going to draw a rectangle around our whole picture. Okay, a rectangle around our whole picture. So the domain are how far to the left and right our picture is. Now, since it's touching the left and touching the right with closed circles, we're going to use brackets. So we have a closed circle at 0. Do you see that? And we have a closed circle to the right at +4. And it includes 0 and +4. All right, what about the range? So our points touch the lowest and highest point, and they're closed circles. So the lowest point on our y-axis is right here, correct? So it includes 1 up through 1, 2, 3. And our closed circle gives us brackets. Now, is this, so let me get rid of our rectangle we drew. Is this thing a function? Would it pass the vertical line test? Yes, it passes the vertical line test. It is a function, yes. So we don't have to list any ordered pairs to prove it's not. All right, now look at this last one. This is a great one. You'll definitely have this one in Hawks. So I would draw a line, a rectangle around our picture, but the arrows tell me that our picture doesn't stop. It goes down and to the left forever, and it goes up and to the right forever. Do you see that? We don't have any closed circles or even open circles. We have arrows. So the x values from left to right would never stop. So the domain is from -infinity. Ooh, what is that? That looks exactly like an 8. That's not right. -infinity to +infinity. And what about the range? How low and high does this go? Well, we can't draw a rectangle because it goes both directions forever, correct? So our range is the same. Our domain and the range are both -infinity through +infinity. And is that a function? Yes, it would pass the vertical line test. I would never go through my picture more than one place on any vertical line. So it is a function, yes. All right, what does it say? Let's erase all this mess. If a relation can be graphed in, I never say that word because I say it wrong, Cartesian plane, the relation is a function if and only if no vertical line passes through the graph more than once. If even one vertical line intersects the graph of the relation 2 or more times, the relation fails to be a function, which is called the vertical line test. Yep, we already talked about that. Now, this is another vertical line. So the first thing I said was determine, oh, and I added this. So this isn't on your practice notes. I didn't realize it was already listed. So really, we've already done this problem. This is this one, right? Example 2. So I don't know if it's on your practice sheet. I don't remember. If it's not on your practice sheet, make sure you write this down, okay? Just sketch this. So first of all, the range, the domain and range. So the domain, the only domain is what? You guys tell me. Only -4, right? Only -4 is our x value. And then our range, it would go down and up forever because of our arrows. It'd be -infinity to +infinity. And then it says, is it a relation, excuse me, is it a function? No, it's not a function. Vertical lines are not functions. And then you have to prove that it's not a function by any 2 points on this. It doesn't matter what you choose. So probably I would pick the the x-intercept. I think I said y earlier. Sorry about that. So our x-intercept is -4, 0, and then any other point on the whole line, it doesn't even matter. Doesn't even matter, right? So that proves it's not a function because we can see the x values repeat. All right, so last semester, we had this weird question about domain and range, I think in college algebra. So here is your little cheat sheet. I don't think it was in our class on Hawks, but in college algebra, you're going to be asked about which is the domain and which is the range. So when you get to that question, look at this page. And this will help you out with that question. If it doesn't come up this semester, then you can just completely ignore this page. But if you come across this question, this little page should help you. Okie dokie, we're moving on. All right, now the other thing that you had to do this week is order of operation. But the reason that I think this is so simple and we don't need to spend a ton of time on this is because your calculator will automatically do the order of operation for you if you put it into your calculator correctly. So if you have not yet bought a calculator, I highly recommend the Texas Instrument 30XS Multiview. It's $12 to, I don't know, $14, $15, $16 from Target. You can get it on Amazon for probably even cheaper than that. I don't know. This is a good calculator. The other calculator, dang, I wish I brought the other calculator. The only other calculator I like better than this one is, man, I'll make sure I bring it for class this week. But it allows you to change the base of logarithms, which you will do this semester. And it's also the same price. It's about $12 to $14, $15. And that's the only one I would recommend over this one. This is a great one. This one's gray. Mine, I know mine's yellow. It's because I borrowed it from my school. Teachers get yellow ones, but you can only buy gray ones at the store. But this is a great calculator. But as long as you put it in right, your calculator is going to do the work for you. So if you didn't have a calculator, you would need to remember that little saying, please excuse my dear Aunt Sally, which tells you to always do parentheses first, then exponents, then multiply and divide in order from left to right. And the last thing you do is add and subtract. Now, sometimes numbers are grouped together. That makes you do those first. For example, if they are inside absolute value marks like these, you always would do that first before you do anything else. On this problem right here, the way these are grouped, even though this is a division problem and divide comes before adding and subtracting, In this situation, you have to add these before you can divide. And if you have them grouped together under a radical, like this bottom one, you would have to add before you can find the square root or do exponents. But like I said, if you have a good calculator, it will do that, all of this for you correctly. So for this particular calculator, you do have parentheses. So whenever you have a problem, any math problem with parentheses, you would want to plug that into your calculator exactly the way you see it. So in this problem, we would do parentheses first, which 8 plus 1 is 9, times, now this, even though it says parentheses first, this just indicates that this is a negative number. If you have a number that's in second or third or fourth place and it's negative, they always put it in parentheses. So basically, after you do parentheses, then you're going to multiply. 9 times 8 is negative 72. But when you use your calculator and you put those parentheses around the 8 and the 1, your calculator is going to do that for you. Now, this calculator that I love so much has a fraction button, which is N over D. So if you have any calculator with N over D, you can just plug that straight into your calculator. You make sure you arrow to the right to get out of your denominators. If you don't have a good calculator, you have to find, what's it called? Common denominators. Oh my gosh, my brain went dead. On this one, you'd have to find common denominators, but you must divide before you can add this 1/4. So for this one, you would, you don't need common denominators to multiply or divide fractions. So for multiplying fractions, you keep it, change it, flip it. Here, guys, remember that from middle school, high school. Keep it, change it, flip it. Dividing fractions, you keep the first one, change the sign, flip the second one. You can get rid of your sixes then, and then you can divide both of these numbers by 8. 24 divided by 8 is 3. And then you multiply straight across. 1 times 1 is 1. 3 times 1 is 3. So then we have 1/4 plus 1/3. And then you have to find common denominators. So what times 4 is 12 times 3. So you multiply the bottom and the top by the same number. What times 3 is 12? It's times 4. 4 times 1 is 4. So then you add those two numbers and you get 7/12. That's your final answer. Or you just plug it straight into your calculator. But don't forget your parentheses. If it gives you one, I'm just making sure I'm plugging it right in, 6/8 in parentheses, and I get 7/12. So that's so much better, right? Can you guys see how I put that in there? It looks exactly like the problem, right? There we go, with the parentheses. So last year we started with this lesson and we spent like 2 full class periods, and we were like, why are we spending so much time on this when your calculator does it for you? So hopefully you guys can do these on your own, and then you just want to check your answer. 36 divided by 4 is 9, minus 6 times 2 squared is 4. So then you would multiply 6 times 4 is 24. So then this would be negative 15. Plug in your calculator. All right, on this one, we would do parentheses first. After, of course, we also have to do our exponent. So it would be 2 times 9 minus 1 minus 3 times 8. 2 to the third power is 8. So then we're going to do 2 times 8 minus 3 times 8 is 24. So then we have 16 minus 24, which is negative 8. So you guys try all of these, all right? So 2 times 9 plus 18 divided by 9. So 2 times 9 is 18 plus 2 is 20. Hopefully you got that right. And then we're going to do 30 divided by 10 times 2 times 2 times 2 is 8 plus 3 times 4. So then we do division. 30 divided by 10 is 3. So 24 plus 12 is 36. And then this one, 2 minus 5 is -3. -3 squared is 9 plus 2 minus 25 minus 8. So 9 plus 2 minus 25 is -23 minus 8. So we have 9 plus 23 minus 8. So that would be 32. Oh, dang it. I lost it, you guys. Nope, I lost it. Oh, well. Let's see, what would be that answer? So we had 9 plus 2 minus 25. So this would be 23 minus 8, I think. Right? And then that would be 32 minus 8, which is 24. I think so. Y'all tell me if I'm right or not when we meet this week. Oh my goodness. So like I said, this thing is awesome. Now, when you have the brackets, I mean, this calculator doesn't have a bracket, but then you would do double parentheses. So I'm just going to plug this into my calculator. 9 minus 2 parentheses, 3 times 5 minus 7 squared. And then I do the end parentheses divided by 2 plus 2 squared is 4. Whoops. 4. And now I'm going to end with parentheses and I get 35. Did you guys get 35? Using your calculator is a great skill. All right, so anyway, hopefully you guys got this right. If not, we can go over that more when we meet this week. So you guys have this study skills lesson, tips for improving your memory. What acronyms or mnemonics have you used in this or any other math course? Like, please excuse my dear Aunt Sally. Have you ever come up with an acronym or mnemonic that has helped you? How can you use the tips given in this section during your study routine? How do you best remember things? And how does this section relate to other study skill sections we have read? Now, mnemonics and acronyms really do help people just remember those. I remember when I was in college, I took an Old Testament class, or maybe it was New Testament. I think it was. And some of those books I just could not remember. We had to list them all out in order. And I just made up this crazy sentence that each word was the first word, the first letter of the book, those books that at the end of the New Testament, like Habakkuk and Malachi and all that stuff. Anyway, but making up a crazy sentence helped me remember the order of those books. So it really does help you remember. All right, and then also you need to remember you need to read the study skill section over overcoming anxiety discussion. I know there's a lot of anxiety that is associated with math tests for some people. What is your routine for test days? Do you do anything special? What makes tests so scary? How can you reduce stress and anxiety before a test? How can you reduce stress and anxiety during a test? And what are some good things you can do after you have taken a test? Besides getting a margarita, right? All right, so don't forget. So that is the end of Unit 1, you guys. That's it. So don't forget that all of Unit 1 homework is due by the 10th. Your test is for the Monday, Wednesday class. It's Wednesday, the 10th. For the Tuesday, Thursday class, it is on the 9th, which is a Tuesday, right? So we will review. So Monday, Wednesday class, we'll review the 8th and the 10th. And then the Tuesday class, we get only the 9th for whatever reason. The schedules just worked out that way. All right, you guys. Well, I will see you for class, and I hope everyone has a great week. Make sure you join me live or excuse me, when I'm live, make sure you join me and bring your questions to class when we meet. All right, you guys have a great week.